Okay, so good afternoon and welcome to all those who listen to us, and especially to the panelists intervening in this session dedicated to new space and industry. Later on, we will have a panel dedicated to space industry and health. I will introduce my distinguished panelists as the time comes for them to take the floor. We shall have a first round of 10 minutes each, roughly, and then we will open the discussion between us and possibly with the audience if we get some question via the chat. And I hope that people are not shy and ask questions so that it becomes more lively. Let me present myself. My name is Franco Malerba. I'm almost a collection item. I'm the first Italian astronaut still alive and in love with space. Strong believer of the space economy. And by the way, organizer of the Festival dello Spazio di Busalla in July, where we also have a session dedicated to space economy. So the session is dedicated to space and industry, and the guiding thread of our presentations and discussions will demonstrate, I expect, that the multidisciplinary interconnection between space assets and Earth systems create opportunities for new products, services for citizens and for economic development in diverse traditional industry sectors using space technologies and space data. Well, I think I've taken my 5 minutes rights, and I will go ahead and give the floor to the first panelist. Actually, I take the power of the chairman to change a little bit the order of the panelists. I had a glimpse at what Marco Brancati will be talking to us about, and I think it can play a nice introduction to the next panel on space and health. So I keep Marco steady for the time being and give the floor to Pieter Deleye instead. Peter is business development manager at Verhaert. Correct me if I don't pronounce it correct, managing open innovation in space, working on space technology transfer projects as ESA Space Solutions in Belgium. Besides the technology transfer, Verhaert coaches new space startups in their product design, fine-tuning their offer to terrestrial markets to improve their go-to-market approach. Peter, I guess you will be talking to us about some of your successful examples of technology transfer, how you empower entrepreneurs and you help them in working on space technologies and products. You have 10 minutes and the floor is yours.
Thank you, Franco. And indeed, I'm going to talk about some of our technology transfer. I do have a bit of a feedback, so maybe if everybody can mute, I'm going to try and share my presentation.
If I can suggest that everybody who is not speaking cuts the microphone so we have a better audio. Go ahead, Peter.
All right, I hope you can see my presentation.
Yes, we do.
All right, very good. Thank you for this time. Quick introduction of who I am. Thank you, Franco, for the quick introduction of myself. Quick introduction of Verhaert. Verhaert is actually a pioneering product innovation group, so we are multiple brands, and our vision is to master innovation together with our clients. Now, I see that my presentation is actually not moving. There we go. A short extra explanation on what I do on a daily basis is actually I was focused on technology transfer within or devices to new products. And we've been doing this for the European Space Agency. We are expanding to do this as well for the European Commission, DG Davis, GSA, and also fusion. Actually, since last year, we have now included fusion technologies to do this technology transfer to new industries. To provide you with an overview, and I'm sorry, I tried to make this slide a bit more pretty, but I was not capable of, because there's so much on this. So as mentioned, ESA is our starter, first partner actually to promote technology transfer, and it's only a small block of what we do as ESA Space Solution. We are now working on knowledge transfer, so how can we find new markets, how can we leverage the data from Copernicus, how can we leverage data from GNSS in new markets and from fusion technology. Now, we don't do this alone. This is definitely not an exhaustive list, but some of our partners we deal with on a regular basis to get this to a European market. Quick overview, what is technology transfer specifically, and how has it evolved over time? And I mentioned a bit earlier is that space has always tried to find, to leverage its the return on investment of its investment to non-space industry. And I'm very happy here to talk about what is new space actually doing is increasing the backflow of other technologies, artificial intelligence, robotics, smarter manufacturing, more IoT enabled manufacturing into what we call old space. I call them more established players of the space industry. But we assist here for space companies, for terrestrial industries, to do a quick scan, feasibility demonstration, and maybe even support to certain startups is something that we do. But as this is a panel about health, I wanted to show you what can we understand around this. And this is actually, I have 3-4 cases, which each have a specific asset, are a bit different in the sense that we can transfer hardware, which this is the case for your heat pipes. And as you can see on the top right, it's actually cooling system for satellites, because microgravity, the flow of hot and low and cold liquid is not the same. They have developed this non-mechanical flow, actually pipe, to cool the satellites, and it's now being used in the Paris metro because the metro of Paris was too deep and didn't have enough fans to cool the metro, and so it's a specific transfer of hardware unit. But this is not always as easy, and so we can also start about technology transfer, and this is one of the first technology transfers that Verhaert has worked on. And the specific technology is of measuring the astronaut's health, and specifically its breathing, his heart rate. And the application that we found here on Earth, and as you can see on the picture, it's actually quite an old picture, is the use of this method and data to prevent babies from dying of cot death. It's what it's called in English, but it's I think you all know this as the moment where a baby can die because it just stops breathing. And this is something that we can measure. The same technology has been used on a more recent case, heart kinetics. It's actually cardiac monitoring, and more specifically the contraction and expansion from the heart as well on forward and on the side movement, so that we can prevent or at least detect heart failures a lot more in advance. And this included, we are now expanding the product by including AI to eliminate noise in the data. Another case which is more within the body and also outside the body at the same time. So a solution to the disease of atrial fibrillation is the wrongful contraction of the heart, in the sense that the nerve sends out the wrong signal. And up until before we looked at this case, the surgeon always had to go in and actually burn around the artery to eliminate nerves. And they said, well, we need to improve this because actually 70% of all operations are successful. So that means that people sometimes need to go for 2 very invasive surgeries. So what can we do to eliminate this? And we got 2 technologies in the sense of measuring on an outside basis how the heart contracts, and also a technology with magnetic fields to excite certain materials without connecting, without having a direct contact. So you don't have a blowtorch, you use actually magnetic fields to heat up a certain element. And so what we developed is a new material, and in this form of a stent that is actually put into the heart and then through magnetic waves excited so that the nerve is fully fully burned and actually solving the issue of the operation. So that was clear technology. Now there's also knowledge in the sense that some of our people have worked on payloads, and specifically payloads on microfluidics. And this helped within the case of Fuji Radio, where they came to us asking for a new device, which is exactly the same, which is blood and urine testing, but they were selling a device for 25K, and they said, we need to redesign it, we want to have it for 5K. But that means a whole re-engineering of the device, and it had to become a lot smaller. And as soon as you go small, sometimes physics is not your friend. And actually, our colleagues noticed that what's happening within the machine by scaling it down as much is actually exactly the same effects as they are happening in the ISS due to microgravity. And they figured out ways to work around it, as they did during their space days. And we've been able to develop this product in 2 years, getting it fully certified for the medical industry, which is very, very quickly. I have some other cases, but I'm bound by my time. So just to show, we are not only working on the medical field, we do technology transfer, which is the glue between all these industries, to learn from each other, learn from the different industries, and see where can we apply the same learning for more applications, increasing ROI. And I wanted to close off my presentation, I wanted to give a quick summary of what I've seen today during the different presentations. And actually the first one is, the new space is not clearly defined, so I can't really say what's new space specifically going to do for the industry. But what I do see is that the increased collaboration, the increased talks, the ability to share more information is only going to increase the ability for different companies to work on new products and enjoy the benefits of technology transfer, where we need to make the distinction between a technology transfer which is from space to Earth, a spin-in from Earth to space. But there's a hybrid in between where you can find an application of a space company, space technology, where they create a new company, just like a normal startup. And that I've heard of Thales, Alenia today, and I've heard of the Telespazio collaborations with others to continue. But and then I wrote down some clear abilities of new spaces, the nanosatellites, the Bartolomeo, the NanoRex that was just on the air, provide new abilities to learn about health. And yesterday actually I heard of a new case. There was one where they're going to use satellites to cure cancer, or at least that's the name of the project, where they're going to utilize cancer cells and go to see how do they interact with the medicine in space to see if the medicine can be improved. So interesting cases. Happy to discuss on what's next.
Okay, thank you, Peter, indeed, you also could have been an introductory an introductory presentation to the health panel, because your applications were very much geared to health. I have a question in mind, but for time sake, I prefer to go about the other presentations, and then we open the Q&A session. The next speaker in my list is Gino Bucciol, co-founder of Officina Stellare, and he is the business development manager. He is also head of business development, and I read that the company Officina Stellare has recently gone public, and is listed in the Borsa Italiana, in the Italian stock market, alternative investment market. So it's sort of Italian Nasdaq. It is Officina Stellare is located in the Vicenza area. It's obviously an innovative SME, perhaps is even more than an SME, active in design and production of telescopes, optomechanical and aerospace instrumentation, ground and space-based applications. I know very well the telescopes of Officina Stellare. I don't know about their payloads, but we will listen to that from Gino. Officina Stellare is a rare case in the world of a company managing in-house the whole chain for design to production and startup of complex optomechanical projects for scientific research, commercial and defense-related purposes. And in fact, I heard a key word that I'm sure Gino will be elaborating about, of space farm. So I'm curious to hear your presentation, and I give you the floor, Gino.
Still on mute, Gino.
Unmute your microphone, Gino. Okay.
Here we are.
now we can hear you.
Thank you, Franco. Thank you to give me the chance to discuss, to talk about the commitment of Officina Stellare in the new space economy. Yes, we will talk definitely about our space factory. And by the way, I'm inviting all of you to visit us. I'm always happy to invite the people to visit us, because I'm sure that what we are doing here is pretty unique, at least in Italy. I'm sure that we are all aware of what the space race is. Even if now the steep curve is slowing down a little, it is definitely sure that the space economy in the future will be one of the most important and impacting in the everyday people life. Even if most of the industries are now focused in the downstream area of the new space, coming from the old astronomy field of application, we decided to be focused on the upstream side of the new space. Then we are basically an hardware company. We are designing and building in-house instrumentation and all the enabling technologies that the new space economy is asking for. As you said, in our space factory, we will offer to our customers all the phases of the process. Then the design, the implementation, the integration, and the testing capabilities that are required. This is an extremely important point. New space economy is asking, among many things, especially for a fast developing time of the instrumentation, and also is asking for a low cost of the things. The new space economy passes also through these two important aspects. And this is exactly what we are doing here. We are working on these fundamental steps of the new industrial revolution that the space economy is. exactly what we are doing here is a space factory, is a place where all the processes that are necessary to arrive to a space product will be implemented. In a single place, we will have design capabilities, manufacturing capabilities for both mechanical and optical side. We will have integration capabilities and test capabilities for all the typical steps that are necessary for a space product, and also for some important ground product too. The next 5 years, especially for us, will be focused in the creation of this space factory, and that will be built here from where I'm talking now to you. Talking about the new space economy and being involved, especially in the upstream, in the hardware side, we will decide to be focused especially on 3 main aspects. The Earth observation, an area in which we have been operating for some years. Space situational awareness, or that is known as a sort of control of the orbital traffic, and in the laser communication, with the possibility of having an overall point of view end-to-end on all the technologies that are necessary to enable these 3 application fields. I'm sure that as I said before, what we are doing here is pretty unique in Italy. We are also convinced that these 3 pillars are really connected to each other. And thanks to the investments we made, we will play our cards in the best way in the future. This also thanks to the many engineers. Some of them we have returned from abroad. We are very happy to be able to keep back in Italy some talented and skilled people that were working outside Italy. With them, it is always an important point that I'm happy to remember. Talking about the 3 main pillars, the Earth observation, the first and most important probably for us. Earth observation, thanks to specific instrumentation or satellite constellations, will generate a series of very important applications: smart agriculture, the prevention and monitoring of environmental disasters, and a better management of risks, border control, and much more. The need to transfer this enormous amount of information to the ground will require an evolution of the current telecommunication infrastructure. The current one is already known to be inadequate. The new frontier is the laser communication, very efficient in terms of energy consumption and extremely fast, then a perfect tool to transfer the big amount of data that we have to transfer from the orbit to the Earth. Lasercom will be also used on the ground to ensure the global coverage of broadband communication, internet, and the access to the information. And it will be extremely important enabling technology for some future application like the automatic driving and so on. In addition, Lasercom will be very useful to allow the safety of the information exchange. There is a special niche of the Lasercom, so-called quantum communication, that will allow to transfer information in a perfectly safe way without the chance to hear what the people is transferring. Lasercom, both Lasercom and Earth observation will require for additional assets in orbit. We know that the orbit is already crowded with many spacecraft for a lot of different applications. The new space economy will increase a lot of this number, and it will be important to make the orbital environment safer, preventing collisions, preventing the possibility to have trouble and problems between the orbiting assets. And for this, it will be important to have a space situational awareness control, that is basically a net of ground-based telescopes, some of them also placed in orbit, that will patrol the sky looking for the position of all the objects that are orbiting, and preventing or mitigating the issue of the possible collision between them. Officina Stellare will be active in all these three important fields. It looks very different, but actually they have at the core the same technology, that is a telescope. I'm used to say that in Officina Stellare, we are basically telescopes builder, because this is exactly what we are doing. We are building telescopes for Lasercom, telescope that are an antenna to transmit and receive photons, modulated photons, telescope that are look in the sky for the position of the different objects in sky, and telescope that are looking down from the orbit, taking high resolution picture of the Earth. At the core of all the three technologies, there is an optomechanical system that is basically the job that we are in which we are very good. Let me also discuss a little about the panorama in which we are working now, the scenario in which we are working now. It's I will use a word that we technicians love: system. I may sound trivial, but we need to become systematic. Italy needs to know how to build a long-term strategy that is able to make the most out of the very important supply chain that the Italian entrepreneurs have created. Outside Italy, the other people are doing this very well. In France, in Germany, the industry and the governative people are working together, creating a strategy for the future. And it will be important to do the same also in Italy. The industry, I'm sure that the entrepreneur like us, the industry, have done their job in the very good way. Internal competition is almost inexistent. All of us are working in different fields and creating a supply chain that has naturally been created with a very small overlap and a great complementarity, actually. It's just about working together, talking and joining force. This will be a lot important for all of us. It's also important, the opinion of Officina Stellare is also that there is no possibility of development without technology transfer, that there is no possibility of success without the right interaction and cooperation with scientific people, research people, and university. That's as example. Here we every day we turn to the university world and we are lucky to be very close to active reality and a wonderful university that is in Padua as example. There are many projects that we are carrying out in collaboration with them. And another example is the industrial doctorate, which will take place in our headquarters. I mean, for us it is very important the technology transfer from the university to the industry, and we are doing our best to make that possible.
Okay, thank you very much, Gino. In fact, I was very impressed by your preach for laser communications. I happen to coach two companies who are involved in that. By the way, I understand that laser communications in space are becoming also to ground, say, are becoming important because of networks of satellites. Otherwise, you have clouds in between that may jeopardize the laser communications. But we will come back to that later if we have time. Now I would like to take the ball from where you left it, stressing the importance of technology transfer, and I would like to give the floor to Nicola Sasanelli. Actually, Nicola has an Italian name. I wonder if he has some Italian roots. We have to be very grateful to Nicola because he is with us in spite of the 10 hours difference to Australia. So it must be very late at night in Australia right now. Nicola Sasanelli is the Chief Executive Officer of the Andy Thomas Space Foundation Australia. This foundation is a new organization created recently, which provides an interface between the space community and the wider Australian community. And Nicola is its administrator. The new organization will complement the work of the Australian Space Agency in the many institutions involved in space-related education and training. We look forward to hearing from Nicola about this new organization, its business model, the plans of the Australian Space Agency and the new foundation. And let me acknowledge also and send greetings to NASA astronaut Andy Thomas, the godfather of your initiative. By the way, his wife, Shannon Walker, is presently operating in the space station, so we are very grateful to her for the job that she is doing, and of course also to Andy Thomas. He is probably now more relaxed because he's on Earth working with you. Okay, the floor is yours, Nicola, and tell us. So the next speaker in my list is Federica Bondioli, full professor at the University of Torino, and president of the National Consortium for Material Science and Technology. She will talk to us about her research at Politecnico in the field of additive manufacturing, a novel enabling technology at the core of industrial manufacturing processes on Earth, but also in space, as we heard in several presentations before. Professor Bondioli, you have the floor.
Yes, thank you very much, Franco. I don't know if you can hear my slides.
Yes, we can see your slides and hear your voice, so it's all perfect.
Perfect. So, I mean, everything is okay. Thank you very much. As said, I introduce you additive manufacturing, a family.
To tell you the truth, the slide, you could hit the presentation icon, and it would be the slide would be on the whole screen rather than echo. That's it. Perfect.
That's it. Okay. So I introduce you additive manufacturing. That is a family of advanced technology that today is opening up new design and manufacturing opportunity for space industry, even for the most important parts. Very quickly, what we mean for additive manufacturing. Additive can be used to identify a process of joining materials to make an object from 3D model data, usually layer upon layer. In this context, additive describes a professional production technique which is clearly distinguished from conventional method of material removal. As you can see in this slide, in the images on your right, you can see the same component, a metallic gear that is obtained by the traditional top-down approach, while in the right side is produced by additive manufacturing, a bottom-up approach, starting in this case from metallic powders. The choice between these two different approaches to obtain an economic near-net shape component is a challenging task and depends on several factors. But it's clear that the main strength of additive manufacturing is the exceptional design freedom that influence at the same time and cost of component development. So this means that additive is especially relevant in the production of complex and customized structures that used to be hard, if not impossible, to obtain with traditional technologies. And you can thus understand the importance of additive manufacturing in space industry, where almost everything is custom made. As said, the design freedom also means mass saving, that it's possible thanks to the topological optimization of component design. For example, here you can see the satellite Sentinel-1B and in red, circled in red, the antenna bracket. For the subsequent missions, this bracket will be replaced by a new one with an optimized design obtained for additive manufacturing. And the new bracket that you can see in this image is only 0.94 kilograms with a 40% decrease from the original weight. So for this reason, national agencies and different private companies have been and are conducting research into how to use additive manufacturing in a variety of space-related applications. If we think to metallic components, we are thinking on ground, on Earth, production of components for space missions. In particular, the research is mainly focused on propulsion systems with the goal to reduce part count, cost, and fabrication times, mainly to meet the growing demand of small launchers. However, also in satellite, additive manufacturing has been used, such as, for example, in this bracket that you can see on the slide. In order to understand the process and completely characterize all the different steps that allow to obtain a certified component, at Politecnico di Torino, thanks to the support of the university and of the Piemonte region, the IAM, Integrated Additive Manufacturing Center, has been created. 5 departments are involved in the center: the Department of Mechanical Engineer, the Department of Material Engineer, where I work, the Department of Aerospace Engineering, Electronics and Communication, and finally, the Department of Control and Computer Engineering. The acquired knowledge of all the single groups involved in the center represent an optimal starting point to begin an ambitious route that can only be faced thanks to the skills of the different researchers that are involved in the center. In this moment, we are 40 permanent researchers and almost 60 among research fellow, PhD student, and visiting professor. In this way, we are able to follow all the different aspects of the additive manufacturing supply chain, from the material preparation to the component characterization, from the design optimization to the development of new and controlled systems, for example, using sensors and in live process monitoring, or developing new lasers. Regarding the metal component, Politecnico has the possibility to follow all the steps from powder production to component characterization. In fact, among the different infrastructure, we have just acquired, recently acquired a gas atomizer that has been installed in Alessandria that allow us to evaluate the possibility to develop innovative alloys. The obtained powder then can be printed with different technology. As you can see here, we have 3 different laser powder bed mating systems, ranging from small-scale system with which we can perform the development of new materials, to the production scale equipment with bigger building chamber for component production. But we have also an electron beam melting and a direct energy deposition systems. Recently, we have also acquired a hot isostatic pressing to densify the component already printed or to direct obtain by powder metallurgy the desired component. So in this panorama, from my point of view, materials are the real issues and the biggest opportunities for additive manufacturing. In fact, it's important to underline that there are still few materials available for additive manufacturing, and they cost a lot if compared with the traditional one. In fact, they must have particular and very controlled properties, such as, for example, this spherical shape that you can appreciate in this photo. For this reason, a lot of research is done in the world in the development of new materials. Here's an example of our research. One way that we are exploring is the possibility to develop metal matrix powders to obtain components with higher thermal and mechanical properties, or mix different metals. In this example, we have blended the powder before the printing process, but our new goal is the development of new alloy before the printing process during the gas atomization step. In fact, with this new infrastructure, we could evaluate the effect of different element addition just using the periodic table of element as reference. On this development, we are working in close collaboration with several industries with which we have also formalized different partnerships. A virtuous example, together with Avioareo, we have created the Turing Additive Lab, a joint lab to collaborate on strategic research topics, in this case for the aviation industries. But we are also involved in several European and ESA projects also on space application. Different other technology can be used instead for polymers. The technologies in this case are different for thermoplastic or thermosetting polymers. For the first class, the most used technology is the fused deposition modeling that is powered by a filament. The main materials are ABS, PLA, and with extruder with an head that can reach higher temperature. Also, a very performing polymer such as PEEK can be used. This technology was used in different applications, but mainly to produce CubeSat, especially because additive manufacturing easily allows to embed wiring, electronics, and propulsion systems. Also, in Politecnico, we have several FDM systems, and here you can see that we participated to the CubeSat challenge, and we won the challenge in 2015, optimizing the CubeSat design to minimize the weight and the part counts, and thus set to reduce the cost. With this technology, not the research is done on Earth. Some has been done and is currently doing in space, for example, on the International Space Station, where an additive manufacturing facility were set to produce with a wide variety of thermopolymers, parts, entire experiment and tools that can be created on demand. And in this way, it will be possible immediately repair essential components, upgrade existing hardware, and install new hardware, reducing one more time, reducing cost, mass, and time. So the possibility to use additive manufacturing in space is the new frontier, allowing, for example, the construction of tools, components, or even large structures directly in space, even better if using material directly found in space. That means polymers from the polymeric waste, for example, coming from the packaging, or such as regolite. The ability to build habitat for astronauts on the moon, on Mars, using regolite, the local raw material, could allow to obtain cheaper and simple missions and the possibility to build large structures. So, to conclude, an increasing number of young companies are entering the space industries with the knowledge that additive manufacturing printing technology is able of satisfying the requirement of aerospace industries while remaining cost efficient. So the perspective for additive manufacturing for space and in space are exciting. However, I hope to have underlined you that some issues are to be considered. The need to change the approach to design in order to take full advantage of the capabilities of additive manufacturing. The need to develop new materials with the property required for space application. In particular, an important challenge is the development of microgravity specific materials to obtain new material properties and microstructures. The need to ensure reproducibility, accuracy, and reliability of the printing process. And finally, the need to develop new stuff. So I think that I have to stop here. Much more said on this topic. Here my email address. I'll be more than happy to answer to all the questions.
No, thank you very much, Federica. It's a fascinating perspective, this manufacturing in space. In fact, I'm sure all the panelists and myself would have further curiosities. Unfortunately, the time is running, and I think I need to go ahead with the next speaker. In fact, now Nicola is ready.
Is working, Franco?
Yes,
it's
I can
working
hear you.
now.
Now it's working. Right. So
okay,
I already made your presentation, so we know who you are. Did you hear my voice when I was talking about you? Yes, you did.
Yes.
So please, you have the floor. 10 minutes to talk to us about the Andy Thomas Space Foundation in Australia.
Yes, maybe I can provide some background about the space in Australia. That, as you know, the space agency was established 3 years ago, and in 2019, so it's quite young. But probably you are aware that we launched in Woomera in 1967, what is considered the third satellites from the owner country. So for many years, the space was not considered a priority for this country. So just during the International Astronaut Conference in 2017 that we announced the new space agency. So is a quite vibrant ecosystem after 3-4 years. And we, at the moment, we have a sort of 800 business or research organization involved in Australia, with 14,000 direct employees, with a revenue more or less 5 billion Australian dollar. It's quite important because the ambition is in 2030 to achieve 30,000 direct employees and 12 billion dollar revenue. So the space agency is working quite well with some thematic area that, of course, are in line with what the European Space Agency and the NASA is doing. So when we start to think about the space agency, we thought that an important activity of the space has to be a sort of R&D. So we established last year what we can call the Smart SAS CRC, that is a sort of R&D activity, $245 million over 7 years. So, but after that, this year we start to think about, some education, the education file. So you can imagine the big picture. We can have the, the governance from the space agency, then the R&D managed by Smart SAS CRC, and then education by the Andy Thomas Foundation. So it's just established in July this year, and of course is a board of directors. And we have a 3 important pillars, and that is education, outreach, and in some way innovation. So what we are doing, what we intend to do in terms of education is one important activity that we already set up is a professional development course for STEM teachers. So try to educate the teacher and in particular parents that is in some way close to the student that are interested in being involved in STEM subject. And of course, what we have in mind is to manage the Discovery Center, that is sort of a space museum that will be launched in March next year in Adelaide. So advanced space education is an important asset of our mission. Then we have the awareness, and in particular, what we want to do with this is bring space in the community. So try to organize events, that is forum, seminars, but not just for space, but for the day-by-day people, and try to educate people how is important the space in our daily life, and in particular, use space technology to innovate and start to become more competitive some traditional sector like agriculture, mining, transport, etc. And of course, what we have in mind is encourage a new generation of space leaders that, at least in Australia, is quite important because as a new sector is quite important to involve, young fellow. The last part is contributed to the national space community. So is running, what we intend to do is running National Space Forum. We already have this space forum. Many of our colleagues from ASI they know. Giorgio Sacoccia was with us in February this year, and I think that is an important event, in particular for industry and research organization from Europe and from USA that intend to be involved in the Australia ecosystem. So Australia has quite important opportunity. Defense is one, but also we have more than 1.4 million companies that they need space technology in order to improve themselves, in order to become more competitive. So I think that Australia in the next couple of years has become an opportunity for the mature company that exist in Europe and in USA. So that is the main the background, or the main pillar, or the main dress that we want to do. So our vision is, as we said before, is take care about the ecosystem. So we have at the moment in Australia around 700, 800 organizations. We need to growing, and we need to growing means not only push our startup to become a scale up, but also attract company here and try to be involved in our ecosystem, as well as attract talent. We have many researchers and also experts that they come to Australia in the recent year, and the new head of the space agency, the Australian Space Agency, is Enrico Palermo, that is Italian background from Virgin Galactic, but was educated in Western Australia in Perth. So these strategies start to work. So the Andy Thomas Foundation intend in some way to be protagonist of the growing of this space, of this ecosystem. Our mission, of course, is promote social well-being, support space education, and in particular inspire young students. And that is quite important, because for us, the year 9 is represent an important year for the young students. So we intend to work with the school and try to identify some opportunity to, in some way, sell space as a way to inspire young students. But at the same time, we need also to building a culture of entrepreneurship. This is quite important here in Australia, because the majority of students, when they finish the bachelor and sometimes also the PhD, what they want to do is just find a fantastic government position or work in the industry, but there isn't up to now the culture, to take a risk and become an entrepreneur. So we try to do to work in this is of course a cultural aspect, but the foundation want to in some way provide a sort of help in this. And our purpose, of course, advanced space education, raising space awareness, and contribute to the national space community. That is something that we really would like to do, and we already start to identify some activity with school, entrepreneurs, university, and research organization. What we are in mind in terms of the outcome is really be involved, and that with, of course, working with the Australian Space Agency in the grow the space capabilities in Australia. So growing our industry to expertise and capability that we need to in some way work together. Just last slide for me today is we are looking for partners that can share the same value, and our value in this particular moment is exactly what you can see in our slide. So power of education, pursuing excellence, and of course diversity inclusion is quite important in this country, and that is for example is indigenous people involved in the space that is quite important for us, as well as women in the STEM subject that still has a small percent of the population. I would like to leave it as it is, and ready to answer some questions.
I think we have lost Franco for the moment.
Yeah.
Okay.
Actually, we lost Roberto as well.
Okay. Maybe there are just to take time into consideration. We still have two panelists right now who have a presentation due. So Yossi and Pietro, I don't know, you're aware of the schedule, but maybe Yossi, you go first and present.
Okay, we're back online. There was a little glimpse in the connection. I thank Nicola, whom I don't see anymore, but oh, here you are. Okay. It was, in fact, very enlightening, your presentation, because you gave us the perspective of space as becoming almost a, how shall I say, social tool to develop the Australian society, with the education, with entrepreneurship, all kind of, all values that certainly we share. And the fact that Roberto Sacoccia was visiting you is promising that there will be further cooperation between Italy and Australia in the space sector. Now, I move to the next speaker, Roberto Provera, old friend of mine, by the way, from Thales Alenia Space, Director of New Initiatives and Innovation, Exploration and Science. Roberto's background covers everything in the life cycle of space, engineering, project management, business development. He actually led Thales' effort for its most successful commercial space sales, such as the Cygnus pressurized cargo module to Northrop, the Bishop airlock that we heard about by Jeff Mamber only a couple of hours ago, with Nanoracks, and the pressurized crew cabin for the moon landing system of Dynetics. Roberto is also a member of the scientific committee of the Amaldi Foundation, who is our host today, and of the steering board of the Piemonte Aerospace Cluster. So I welcome Roberto, who will tell us about the Thales Alenia perspective of commercial opportunities in the field of human spaceflight. So you have the floor, and I see already your slide on. It's not in presentation mode, but if you can just make it full screen, it's better.
Is it in at full screen now?
No, I don't see it in full screen. I don't know. There are some mysteries in the video conference. But
just one moment, I'll try again. Let's see if I can make it work. Let's see.
Now I don't see it anymore.
And now, no, it doesn't work.
You have to share the screen.
I did it. Or at least I thought I did. Sure. Let me do it again.
Almost good. No. No.
Of course, I tried a couple of times before, and everything worked well now.
I can confirm.
Yeah, we've got to become familiar with the system. It's not the easiest in the world.
Okay,
That's
okay.
Okay, thanks, Franco. Thanks for your kind introduction, and thanks to the organizer for giving me the opportunity to speak at this amazing event. Well, in my presentation, I will address space economy seen from the perspective of a large system integrator, and I will focus on the experience and on the plans that we are doing for space exploration. And I'd like to surprise you. Instead of the usual picture of the space station, I'll start with a picture of water, because I'd like to make some comparison. Well, first of all, let's start from the big picture. And space is a resource, and as for all basic resources, everybody should have access to space. And as for the terrestrial resources, new business models are possible also for its exploitation. And the water, I think, is a good example, because water is a precious resource, should be available to everybody, but at the same time, you don't need to own a well or to be an expert of hydraulic engineering or have a purification plant and so on. You just need to have a provider or infrastructure that brings water to you. And this is what we want to do as a Thales Alenia Space. We want to be the provider of infrastructures for the space user, for the cool community. And so how does that fit? How do we fit into the picture of a space as a resources? Well, when we think to space economy, we have immediately the idea of the infrastructures that should be affordable, multi-user, user-centric, flexible, multi-mission, and I believe we have the right heritage and mindset to be part of the space economy. In fact, we have well, more than 40 years of experience in human spaceflight that, according to me, is one of the next wave, one of the major next wave in space usage. And we look for fruitful partnership and new business models. We have an integrated portfolio that can support the space economy. We have infrastructures that cover different locations from LEO to Moon surface and beyond. And we are able to work, we have experience to work with different partners, different customers, from agencies to SMEs to large prime contractors and of different nationalities. And finally, we bet on private investment and PPPs with agency to pursue the space economy. In the next 4 or 5 charts, I will make some examples, and I will start from let's say, quote unquote, old space, that is the International Space Station. I'm not meaning you, but basically it's more than 10 years that after we have contributed to build the station. We and Altec, a joint venture between Thales Alenia Space and ASI for the operations of the International Space Station, we are taking care of the station. And together with ESA, with Altec and the other colleagues in Europe, we have started a discussion on, we are planning for a modernization of the campus, so to be more flexible, so to be more interesting for space from a commercial use, so that it can upgrade the offer for microgravity. And speaking of commercial usage, Jeff Mumber just 1 hour ago spoke about the wonderful Bishop Airlock. We partnered with NanoRex for the development of the Bishop Airlock. And it was an extremely interesting experience. We, as a large company integrator, that were supplier to medium enterprise. I must say that the relation worked really well. we learn each other. We learn how to work together, and that's, I think, enriched both of the companies. And as Jeff said, it's the Bishop Airlock is already at the station. It will be integrated at the station in a couple of days. And on the bottom right of the slide, you may see the Bishop Airlock in the Dragon vehicle that is approaching the station. One of our major success story in commercial space is the Cygnus vehicle that is a cargo carrier for the International Space Station. It's a partnership with Northrop that is lasting now since more than 10 years. We started signing an agreement between the two of us to develop commercial space, and we invested. Northrop Grumman invested. At the time they were orbital, and then this big adventure started of commercial cargo transportation to the space station, and now we are producing almost a series of these carriers for Northrop Grumman. We are at 18, and we plan to do more. It's a huge number for human spaceflight. And I think I'd like to underline one point. We reached that level to be able to partner with a US company in a commercial arena because there were initially investment made by our government and by ASI when the space station began. There was the decision that Italy would grow in the human spaceflight. And so Italy decided to participate. We as industry grew a lot, and the complete supply chain, just to make a comment to what Gino said just half an hour ago. And I think based on what the government allowed us to do with the funding, we grew, and we are now one of the major players in the commercial arena. And I think this is a good example of how the government investment can be used. I hear a sort of feedback when I speak. Maybe.
Well, actually, there is a session going on.
Oh, ok.
C'è stata una sovrapposizione. Vai avanti, Roberto.
Sì. So the next step after the ISS is, or at least will be private stations, and again we are at the forefront of the agreements in partnership with other companies. I mentioned Axiom Space. It's a private company. We are supplying to them the pressurized elements for hosting their crew and their astronaut and the visitors of the station. And this is according to us a good plan where starting from an infrastructure that is already existing, you can develop capabilities and business to become independent and to grow economy. Well, the commercialization of space is not just going to the space. It's not just do some cool stuff there. It's also bringing something back. And after the flight we made of the intermediate experimental vehicle that you may see on the screen, now we and Avio are bringing back Europe to the ability to return after having operated in LEO the experiments. And this, according to us, will open a huge opportunity for commercial exploitation of LEO, an agile platform that can perform experiments and then bring them back. It will be a complement. It will not be a competitor of the International Space Station because they will serve different users, different scientific and technological applications. And so we have in our plan to to be active in both the station, the commercial station, and the reusable re-entry platforms. I think anyone knows that now that the plans are set for lunar exploration, human lunar exploration, and as Thales Alenia Space, we are already positioned to be the ones that will contribute to the build-up of the lunar station, lunar orbital station, and in doing that, we will serve both ESA with the international habitat and communication and refueling element, and at the B2B level, Northrop Grumman, again, based on the experience of Cygnus, we will develop for Northrop Grumman the HALO, that is the first habitat and the logistics outpost of the International Space Station. The further step will be the moon surface, and we are working in partnership, again, in a sort of strange partnership. There is an intergovernmental agreement between Italy and US, and therefore at the agency level, and there is a B2B initiative with between Thales Alenia Space and Dynetics. Again, this is another achievement we could make thanks to what we learned through what our agencies and these allowed us to do on the institutional programs. And the final step, of course, will be the lunar infrastructure. And this, again, is another giant step for us. We are preparing. There is we are ready to support a government, Italian and US government agreement for placing the first infrastructure on the moon. And we are not talking only about habitats, but pressurized rovers, cargo. And all these will have to be served by an infrastructure of communications, navigation, time distribution. And we, with our colleagues of Telespazio, are already preparing for this service that will target all the infrastructures and utilization of the moon surface.
Let me say just one word. I'm told that there is a return. Those who don't speak should turn their microphone off, please. Sorry for the interruption.
No problem.
Roberto, you may conclude.
Yes, I'm going to conclude. This is just a picture. We are just planning. We are not yet mining asteroids. We are not yet mining moon. We have plans. We are discussing with some potential partners. Just to say, stay tuned. Sooner or later, we will also target this exploitation. And by the way, I think what was said just before about in-orbit manufacturing, in-orbit assembly, that of course will be one of the assets that will be used. To conclude, we also are entrepreneurs as Thales Alenia Space. We are not only to be seen as a large industry. We, through the innovation cluster, our innovation cluster, we nurture new ideas. We make them grow within internal ventures that are basically small startups, internal startups. We team with startups. We monitor continuously the startups to discuss, to work, to understand how the new ideas and new products can be integrated into our systems. And to conclude, we are back to the beginning when I said that space is a resource, and we really believe that is one of the major resources that humankind have, and it is the horizon to build a better sustainable life on Earth. And that concludes my presentation.
Thank you very much, Roberto. In fact, you deserved more time for all the beautiful slides you showed us and all the perspectives you gave us. Unfortunately, I'm running out of time. We are eating in the Q&A and probably also in the coffee break, but never mind. We go ahead. We carry on.
I tried to be very short. Maybe I didn't succeed.
No, but you did right. You did right. It's my fault. Now let's move to what was meant to be the first presentation by Marco Brancati. We moved it to this last slot of this panel because he will be talking about an application related to health, and in the next panel we will be talking about health. So Marco Brancati is Chief Technology and Innovation Officer at Telespazio, responsible at the translational level because Telespazio is an international group of innovation and technological governance. Marco Brancati earned this responsibility after a career of technical and management responsibilities in Telespazio since 1990. Was involved in the development of satellites for Iridium, Astrolink, EUMETSAT, and many others. Was responsible for Telespazio institutional programs such as SICRO 1B, Athena, Fidus, served as head of marketing and commercial planning for satellite system and services division, and now senior vice president, network and connectivity business unit at group level. Today, Marco will report about techniques born in space which help prevent and mitigate pandemics such as COVID-19. Marco, the panel is yours. The floor is yours. If you manage in 10 minutes, I will be grateful. And if you don't manage, too bad, we will carry on.
Okay, Franco, thank you a lot. Thank you to the all colleagues, all the topics addressed up to now. Really very, very interesting. Okay, so I'll try to be very short. Give me just 20 seconds to say a few words about Telespazio. Telespazio is a satellite service provider, probably the oldest one in the world, established in '61. So next year we will be 60 years old. Telespazio is controlled for 2/3 by Leonardo, 1/3 by Thales, and together with the colleagues from Thales Alenia Space, we built the so-called Space Alliance, organized from a business standpoint in 3 transnational line of businesses: geoinformation, SATCOM, and satellite systems and operations. So this is important to understand what I'm going to say just in a few seconds. Focused on midstream and downstream, and from a geographical presence, organized on 8 different countries in Latin America, Brazil, and Argentina, and in Europe, in addition to Italy, we are present in Spain, France, UK, Germany, and Romania, with more than 2,500 employees as a total. Okay, so I'll shortly talk about the space technologies, as said, capable to support doctors, authorities, let's say, and countries in the fight against COVID pandemic. In particular, let me say, I'll show you that Telespazio is developing a sophisticated combination of geoinformation and satellite communication services, of artificial intelligence and big data analytics to struggle against the spread of virus and to address the emergencies. So in the summary, you see the 4 projects I will address, and I can tell you that all the 4 are projects that confirm themselves as a concrete examples of how the space activities can improve the life of Earth, on Earth, and that is why Franco wanted me to be the connection ring between the first portion and the second portion of the presentation. So let's start with with the project Earth Cognitive System for COVID-19, shortly named ExpoForum. So in order to answer to a request from ESA, we developed the ExpoForum platform that processing data from taken from satellites and from internet is capable to identify and reports any gathering, so any source of virus spreading in terms of people crowding. How to do that? Using artificial intelligence and predictive analysis systems to integrate either Earth observation and positioning information with those generated by web and by social network. The project actually helps to isolate new outbreaks by monitoring the areas with a higher concentration of people. Actually, you see at the very end, the result is the development of a mobile application that is based on some pillars. So one is the cluster area identification, then intelligent satellite tasking, object detection and business intelligence, tracking, logistics, and of course, study of how a pandemic develops and how public health can be supported. Actually, in this slide, you see all the steps that the project runs in order to allow the application to provide the solution. So we start from a collection of data crawling. We process the data. On the basis of them, we are able to perform satellite or drones tasking, actually. Then there is the crowd detection and the crowd tracking, the selection of the best path for the users, and then the user alert. Let me say that this project actually was based on some important building blocks, a couple of platforms which are already part of our renewed ground segment product portfolio, and which are EASE and CLEOS, and it addresses 3 of the sustainable development goals as they have been defined. What is important is that this project has been awarded as the first prize for the category health emergency by the United Nations Innovation Development Organization. It occurred on last July. Actually, we were out of 1,100 projects. We were in the category I just mentioned, so the health emergency category, and with 390 participants, and so we were awarded about that. So it was really, really important. Let's move to the second project, the so-called Hermes. It stands for Healthcare Emergency Support System for the distributed response and monitoring of epidemics in the society. And so actually it is a kind of ecosystem of services supporting hospitals to respond to health emergencies. We have a partnership with the Armed Force, which is part of the project. How does it work? By combining Telespazio hybrid communication network. When I say hybrid, I mean both terrestrial and satellite. With the DGOS data center, Hermes is able to support hospitals and first aid units from screening to prevention, from the monitoring to support to the logistic activities. So with the support of our partners, which are quite important in this project, they are the Italian Red Cross, the Gabriele D'Annunzio University of Chieti and Pescara, the Biomedical Campus of Rome. Actually, Hermes allows to plan the pandemic developments over the time, to support the health logistics management, to perform a more efficient distribution of resources in the area, identifying persons possibly affected by COVID thanks to a particular product which is able to perform analysis of the voice. So this the purpose of that is to help hospitals not to be overcrowded in such a situation, to perform a preliminary screening on the field, and on the basis of that, supported by either, as said, the Red Cross, but also the military organizations, to better address the persons based on their physical status. So the main pillars of this system can be seen here, quickly summarized. There is the architecture, again, based on an hybrid solution. You see the medical screening kiosk, which have been developed on purpose to be installed on ground. You see the hybrid network, but also the data center of our controlled company, Aegeos, where the big data analytics actually are processed. Let's move to the third project, which is very interesting. It's a project that it's a trial more than a project that we have in place with Ospedale Pediatrico Bambin Gesù. It's a very important hospital in Roma area. And actually, what did we do in this case? We utilized and tested our innovative platform developed to manage a fleet of drones. So the platform is named T-Drones. So T stands for Telespazio, Drones, Mobility Enhanced Services. And with the support of Leonardo and the hospital I just mentioned and the ENAC, actually we transported the biological samples and the biological objects, let me say, generous, using electrically powered drones. And the first phase of the testing was carried out in October between the collection center, let's say, and of Santa Marinella and the analysis center of PoliTo, the distance between which is 30 kilometers, in an automatic mode using the digital cloud-based T-Drones platform that we developed, allowing to plan and manage such a flight. So it was the very first time that from two sides of the same hospital, there was the transfer of this kind of objects using drones. Actually, let's move to the last project. And let me say, this is another application of geoinformation. It shows how also to perform a post-pandemic analysis, how we can use geoinformation techniques to better understand the consequences of the pandemic. Actually, our artificial intelligence systems are capable to monitor the economic trends with particular focus, in this case, of the ports and the logistic activity within them, and focusing on the freight transport. So, looking at the number of ships entering and leaving the port, we are able to compare business trends in the period 2019-2020, and thus create indications for future trends. Actually, you see here organized per ship type, the different routes. We talk about cargo, tankers, fishing, passengers, and looking at the analysis in 2020 that is in the picture and comparing them with the 2019, we see that the density map for cargo was still, let me say, the same, very similar, but a significant reduction of traffic concerning tankers, concerning fishing, and concerning passenger ship. So this is just to say in conclusion that space innovation and technologies are for sure keywords to address the emergencies and to propose serious concrete solutions that can guide ourselves towards the recovery. And that's it on my side.
Caro Marco, thank you, Marco, for a timely, for a good control of time and for a very interesting and dense presentation.